So we're going to do a few other trig equations that were not covered in Mr. Richard's videos. We're going to start off with this one. 2 sine squared x minus 1 equals 0. And the approach is going to be the same. We're going to factor it. So those are your factors, 2 sine x plus 1 and sine x minus 1, both equal to 0. So it means that the zero product law says that you set each one of them equal to 0. So if we set sine x equals minus a half as our first equation that we have to solve, it does mean that x itself is equal to the inverse of sine of minus a half. Okay, now I don't want you to go to the calculator to put in the minus a half with the inverse function. I want you to put in positive a half. Whenever you get a sine to the minus 1 or cosine or anything else to the minus 1, always put in the positive ratio that you have or the positive value that you have, and regard the answer that you get as being the deviation from the x-axis, and I'll explain what that means. You're going to get pi over 6 if you put sine to the minus 1 as a half. And you see, I didn't put x equals, I put x prime equals. What I'm going to do now is to look at which quadrants I'm going to put that deviation in. For sine to be negative, I need to be looking in quadrants 3 and 4. So I'm going to be deviating from the x-axis in those two quadrants so that I have an angle of pi over 6. So if I want, for instance, to get pi over 6 into the third quadrant, that's going to be pi plus pi over 6. And if I want to get a pi over 6 into my fourth quadrant, I'm going to take 2 pi minus pi over 6. So here are the two results that I'm looking for, right? That means that the two answers that I'm going to get are 7 pi over 6 and 11 pi over 6. On the other side, it's much more cut and dry, much more straightforward. Sine of x is equal to 1, and therefore x is sine to the minus 1 of 1. The answer is just simply pi over 2. So here are my answers, all of them. And I put them in ascending order. Some teachers are very particular about that. I don't really care that much, but they are in ascending order as presented here. So pi over 2, 7 pi over 6, and 11 pi over 6. You can actually check this by graphing it. Here is the graph, and you'll notice that the zeros or the x-intercepts would represent the solutions. And that makes sense because we set the equation equal to 0, so the zeros should be the solutions. So as you can see, pi over 2, 7 pi over 6, and 11 pi over 6 are the x-intercepts of the graph. Okay, so let's try another one. This one is a cosine function. So it's 3 cos squared x plus 5 cos x plus 2 equals 0. The approach is the same. We're going to factor it. So we're factoring it into 3 cos x plus 2 and cos x plus 1, both equal to 0. If we take them individually, we're going to end up with this 3 cos x equals minus 2, which of course means that cos x is minus 2 over 3. Same result. We're going to ignore the fact that we're trying to get a cosine to the minus 1 of a negative angle. So that means that I'm going to be taking it for the positive 2 over 3. And I'm going to get the deviation that I need, and then I'm going to look at the quadrants. So here is what I call x prime. Now x prime means that I'm not actually finding x. What I'm finding is the deviation from the x-axis, and then I'm going to apply that to the quadrant that I need. Okay, so we're talking cosine here. So I'm looking in quadrants 2 and 3, and I'm deviating from the x-axis that would give me a second quadrant angle and a third quadrant angle. For a second quadrant angle, I'm going to be taking pi minus this 0.84107. That would put me in the second quadrant. For the third quadrant, I'm going to be taking pi plus the 0.84107. So there you go. Plus and minus 0.84107 gives me the two angles that I need using the deviation that I got from the calculator. And there are the two answers rounded to 2 decimal places, which is the accuracy that was required. Let's go on the other side. That's just cosine of x is equal to minus 1. And that's easier for us to come up with because we've looked at this before. The answer is therefore equal to pi. So I have 3 answers. I have the 2.3, I have the pi, and the 3.98. Again, I'm putting them in the sort of order of size, although, as I said before, that's really not a big deal for me. Here's a graphical representation of that. You'll see the pi in the middle and the other two angles that we got on either side of that. Those are your zeros. Obviously, there are other answers, but bear in mind that we're only looking for answers between 0 and 2 pi. If you look at the graph that we're seeing right now, you notice that if you're only restricting your search between 0 and 2 pi, there are only those 3 possible answers. You might see some others over on the side, but the only 3 that matter to us are the 3 that you can see between 0 and 2 pi. So here's our last question. And you might notice right away that the interval that we're going to be restricting our answers to is different from what we've had before. We've been accustomed to 0 to 2 pi. Now we're looking at minus pi over 4 to 3 pi over 4. It's a shorter interval. It's about pi radians long. And that is negative on one side is something we need to pay attention to, because we have questions like that sometimes. All right, so let's get into it now. We have 6 sine squared 2x plus 5 sine 2x plus 1 equals 0. We're going to factor it the way we normally factor it. Also notice though that there is a double angle involved this time. So that is going to change things as well. We need to understand how to adjust our final answer based on the fact that it's sine squared 2x. All right, so we factor as we normally do. So we have 3 sine 2x plus 1 and 2 sine 2x plus 1 as the two factors. We're going to set them equal to 0 as we normally do. On one side, that is going to lead us to sine of 2x being equal to minus 1 over 3. We have the minus thing again we have to deal with. And that 2x is therefore equal to sine to the minus 1 of minus 1 over 3. So we know what we do. We're going to look at this as if it was positive 1 over 3. And we're going to find sine to the minus 1 of that. All right, so here's our deviation, or 2x prime. That's not what 2x is. Or 2x prime is 0.3398. So we have to do two things. We have to, first of all, look at this as a deviation and figure out which of the quadrants we want to be looking for the answer in. We want to look, because it's sine, into quadrants 3 and 4. But there's something else. We were told that this is going from minus pi over 4 to 3 pi over 4. But we have to divide those answers that we get by 2 at the end, because this is 2x equals something. So you know we have to divide by 2 to get the value of x. And what that means is that we actually have to search in a wider area than the original intervals, because when we search in that wider area, then divide by 2, we'll get back into the actual region or interval that we require. So we're going to take the minus pi over 4 and we're going to double it. Here's a good way to double minus pi over 4. Just take the denominator and divide it by 2. That has the same effect as multiplying the top by 2. So you're going to end up with minus pi over 2, as you can see here. And we're going to do the same thing with the 3 pi over 4. We're going to double that. So that means that we're going to end up with 6 pi over 4, which is the same thing as 3 pi over 2. Okay, so we're not looking in the original interval, we're looking in this wider interval. So from minus pi over 2 to 3 pi over 2. And we're doing that, just to remind you, because we have to divide our answers by 2 at the end, and that will bring us back within the correct interval. All right, so we now have that 2x is equal to 0 minus 0.3398. Why is it 0 minus 0.3398? You need to bear in mind that we are now rotating clockwise. That's a negative rotation. So for us to be in the fourth quadrant, which is what we need for sine to be negative, we have to go towards that pi over 2, that minus pi over 2, by rotating in a clockwise direction. Right? So we're going to take 0 and we're going to minus that deviation. Our deviation is 0.3398. We're going to minus that from 0 to get to our first angle. And our second angle, we're going to rotate in the normal anti-clockwise direction. So we're going to start at 0. We're going to go in our anti-clockwise direction for a positive rotation. So remember, we're trying to get to quadrant 3 now. So it's going to be pi plus that deviation of 0.3398. So there are your two values of 2x. 2x is equal to both of these, so it means that we're talking about minus 0.3398 and 3.4814. But remember, those are 2x, so we have to divide them both by 2. So if you divide them both by 2, those are your values of x. Remember, the original 2x values that we got were not in our range, not in the interval that we were looking for, but dividing by 2 brings it back into the interval that we're interested in. So those are your two answers right there. Same thing on the other side. Sine of 2x is equal to minus a half. So we're looking therefore for sine to the minus 1 being minus a half. But of course we know for 2x prime, we're going to just simply regard it as being positive a half, which is a deviation of pi over 6. We're going to take that pi over 6 and do the same thing with it that we did for the left hand side, which is we're going to look for an angle which is in a positive rotation taking us to the third quadrant and a negative rotation taking us to the fourth quadrant. So we're looking for 0 minus pi over 6. That's going to take us to the fourth quadrant using a negative rotation, a clockwise rotation. And then we're going to take pi plus pi over 6, which takes us to the third quadrant using the same deviation of pi over 6. Remember, we always just look at the deviation and the quadrant to help us to figure out where our angle is. Each of these angles has to be divided by 2, remember. So we have 2x is equal to these two things, minus pi over 6 and 7 pi over 6. A good way to divide by 2 is to do the opposite of how we multiply by 2. To multiply by 2, we divided each of the denominators by 2. If we want to divide by 2, it's the other way around. We multiply the denominator by 2. I know it sounds a little sort of strange or backward. So it means that our final answer for x would be minus pi over 12 and 7 pi over 12. Okay, so here are our final answers. In order again, minus pi over 12, minus 0.17, 1.74, and 7 pi over 12. Let's look at the graph just to confirm what these values are. If you look again, and remember we're looking now only from minus pi over 4 to 3 pi over 4. And if you look, you'll see 4 values that satisfy that interval. Okay, that's the end of that. There are some other questions that I'd like you to look at. They're from the textbook on page 289, 26 to 28. I won't go into them here. I'd like you to try them on your own first, and then there'll be another video that will cover how they're done, but after you've had a chance to give it a try for yourself. All right.